Hello, dear student. I'm Paul, sir, and today I'm continuing with the other part of the thermodynamics. As we have seen last time, only few definitions like what is thermodynamics, what is system, surrounding, then boundary, how many different types of systems are there. As I told you, three types of systems: open, closed, and isolated. Then after we saw the properties of system, there are basically two types of properties: extensive properties and intensive properties. As I told you, extensive properties are those properties of thermodynamics which depend on the quantity of substance present in the system, like mass, volume. And on the other hand, intensive property are the properties which do not depend on quantity of matter present, like temperature, then pressure. So these are actually the intensive property. Density, they do not depend on quantity of matter present. So those are called intensive properties. Then after that, we studied like some properties of state functions. Basically, main two properties of state functions are that. First one, for a system of that state functions, of those state function, there exists some relation that is called equation of state. Correct? And of those, from this equation of state, we can ensure that if you know any two or three thermodynamic properties, then the other properties will be automatically fixed because they are related. They're related by some mathematical equation. Means what I wanted to tell, the thermodynamic properties are not all independent. They somehow depend on each other by some mathematical relation. And those kind of mathematical relations are called equation of state. Sorry. Next property I told you about that thermodynamic property does not depend on the intermediate. Thermodynamic properties do not depend on the intermediate steps. Like they depend on the initial and the final state. For example, I told you about temperature of a body. Suppose initial temperature is T1, then final temperature is T2. So what is the difference of temperature? Will be final temperature T2 minus initial temperature T1, T2 minus T1. But you also know whenever the body temperature is increasing from T1 to T2, it did not take place in a single second, in a single minute. It took long time. And in that long time, there was a lot of changes, so many changes. But at the time of telling the difference of temperature, you never consider those intermediate steps. So this is one very important property of thermodynamic functions. We are only considering only the initial and the final state, right? Thermodynamic properties, they do not depend on intermediate steps. It was the second property. So these were the discussion of our last lectures. Now, what actually today is our topic? Let me start with this equilibrium. For that, let me share my screen. Hold on a minute. Here you see. See, there is some, we'll be going to some slides. Question is, what is thermodynamic equilibrium? So as far as equilibrium is concerned, definition you will get to see. As far as equilibrium is concerned, if anything does not change with time, the process is going on, the system is changing, but thing is that the parameter, some quantities which do not change with time, then those quantities will be said to be in a state of equilibrium. There is a concept of equilibrium. अगर कोई भी चीज टाइम के साथ चेंज नहीं होता है, हम उसको equilibrium बोलेंगे. Here the definition. Our system is said to be in a thermodynamic equilibrium when the state functions of the system do not change with time. अभी state function may be pressure, volume, temperature, ये सब अगर टेम्परेचर के साथ चेंज नहीं होता है सॉरी, तब हम बोलेंगे the system is in a state of equilibrium. This is the concept of equilibrium. Just to make you understand better, let me let me show you this animation. Suppose this is a cylinder. Some gas is enclosed here with a movable piston. Let me consider the position of the piston is A. And when the piston was at A, the parameters like pressure is P1, volume is V1, temperature is T1. And you know, as long as the piston is fixed here at the point A, the inside, whatever gas is enclosed, of that gas, neither P will change, nor volume will change, nor temperature will change. Means as long as the piston is fixed at the position A, the pressure, volume, temperature, they are not changing with, they will not be changing with time. It means it will be said in that way the system is in a state of equilibrium, because with time there is no change in parameters like pressure, volume and temperature. Pressure will be P1 only, volume will be V1 only, temperature will be T1 only. Correct? Now let me do one thing now. Let me change the position of the piston so that the gas is compressed. When the gas will be compressed, then all the parameters, say suppose it is coming at position B, and the parameter have changed. Like pressure will be P2, volume will be V2, temperature will be T2. Now see, in this enclosed gas now, of this amount of gas I'm talking about, once the piston was coming from A to B, at the time of changing the position of the piston, P was continuously changing, B was changing, even T was changing. But when the piston is again arrived and fixed at B, again those quantities has become fixed again. Means as long as the piston is at the position B, neither pressure will get changed, that will be P2 only. Volume will not get changed, that will be V2 only, as well as temperature will be T2 only. But what happened during change from A to B? At the time of changing from A to B, those properties are changing. So from transition from A to B will not be called in a state of equilibrium, because during this transition the parameters were changing. जब पिस्टन ए से बी तक आ रहा था, ये सारे पैरामीटर चेंज हो रहा था, तभी हम बोलेंगे दिस इज नॉट इन ए स्टेट ऑफ इक्विलिब्रियम. बट वंस द पिस्टन इज अगेन एट फिक्स्ड एट बी, फिर से इक्विलिब्रियम स्टार्ट हो गया, फिर से इक्विलिब्रियम एस्टैब्लिश हो गया, बिकॉज ड्यूरिंग दिस वंस द पिस्टन इज एट बी, देयर इज नो चेंजेस अगेन P2, V2 and T2. So these parameters will remain constant. Thermodynamic functions, properties will remain constant. So this is the concept of equilibrium. At any point, if there is no change in thermodynamic properties, then the system will be said in a state of equilibrium. I think you understood. See now, next is coming few points regarding equilibrium. That is what we explained. Suppose, for example, a gas is enclosed in a cylinder having a frictionless movable piston. The gas has a definite temperature, pressure and volume, as we give the name P1, V1, T2, P1, V1, T1. You have seen. These properties remain constant as long as the piston is motionless. This is an equilibrium state. However, these thermodynamic equilibrium will be disturbed as soon as the piston is moved. During the motion of the piston, like when the piston was coming from A to B, as you have seen, the macroscopic properties like pressure, volume, and temperature cannot be specified, because they are changing constantly, because these properties will change continuously as long as the piston is in motion. This state in which the piston is moving is a non-equilibrium state. जब ये तो A से B आ रहा था, तभी हम बोलेंगे that is a non-equilibrium state. When the movement of the piston is stopped, एक बार movement stop हो गया piston का, the thermodynamic function will remain constant again, and the system will be in a new equilibrium state. So this is what the concept of equilibrium. I think you understood the animation as what I told is also in the form of right. It is written. So now the next topic, next definition is coming. It is thermodynamic processes. The process word you are using every day, but what actually the definition of scientific process? See, the transition from one equilibrium state to another, as you have seen in our animation, it is from A to B. There is a transition. The transition from one equilibrium state to another is called a process. This means a process gives a path or operation by which the system changes from one state to another state. मतलब प्रोसेस ऐसा एक ये है, that is the actually, as in our example it was the movement of piston, but not always. In other case it will be another it will be indicating some other thing. Like this means the process gives the path or operation, means how it is carried out, कौन सा path से carry out हुआ, by which the system changes from one state to another state. That is called a thermodynamic process. As in our animation you have seen from state from A to B, E was one equilibrium state, B was the other equilibrium state. तो A से B तक आने का जो method है, that method is called process. The different type of processes are very common in thermodynamic as given below. तो दो अलग-अलग type का जो process है हम यहाँ पे discussion करेंगे. Number one is isothermal process. The name itself implies what is isothermal. Iso means same, thermal means heat, and together it is what? It is the same heat, means same temperature. I think you understood the meaning of the word isothermal. See the definition? A process in which the temperature of the system remains constant throughout the transformation is called an isothermal process. मतलब वो process जो carry out के time, at the time of carrying out, you don't allow to change the temperature. That is what the definition of process. And this process will be called isothermal process. In such a process, heat can flow from the system to the surroundings or vice versa. In order to keep the temperature constant, obviously, suppose in the system heat is generated. If heat is generated, then heat has to be given out. Then only the heat or temperature of the system will remain constant. Or in that process, the heat is absorbed, right? So the temperature has to be kept constant. So in this isothermal process, the system either has to release some heat or has to absorb some heat in order to keep the temperature constant. Means in simple statement, what I can tell, in an isothermal process, there has to be some exchange of heat between the system and the surroundings. Then only the temperature will remain same. It is called isothermal process. If the process is exothermic, मतलब process में अगर heat develop होता है, the heat will be released to the surroundings, and if the process is endothermic, then heat will be absorbed from the surrounding in order to maintain the temperature of the system constant. Exothermic, heat will be released, endothermic, heat will be absorbed, so that temperature of the system has to be maintained. For isothermal process, the change in temperature throughout the process is zero. Obviously, matlab throughout the process, if the temperature is not changing, then what will happen? If I take the initial temperature, final temperature, if I subtract them, final temperature minus initial temperature, the difference will become zero. That can be mathematically written in this way. Delta means the difference of temperature, right, is equal to zero, right? It is very important mathematical term we'll be using afterwards also. So in isothermal process, delta T will be equal to 0. So I think student, you understood what is isothermal process. The process in which temperature remains same throughout the process is called isothermal process. Next is coming isobaric process. As you came to know, this baric word, barometer, baric is actually related to pressure. And obviously iso means something will remain same. So pressure will remain same. Any process conducted in such a way that the pressure of the system remains constant throughout the transformation is called an isobaric process. Very simple definition. वो प्रोसेस जिसमें हम थ्रू आउट द प्रोसेस क्या होने नहीं देंगे, प्रेशर चेंज होने नहीं देंगे, तो दैट इज कॉल्ड आइसोबैरिक प्रोसेस. In a laboratory, most of the chemical reactions are carried out in open vessel at constant pressure. Means whenever you're carrying out any experimental laboratory, suppose you're carrying out reaction in test tube, then test tube is open and it is under 1 atmospheric pressure. So since it is under 1 atmospheric pressure, right? Suppose uh, in a laboratory experiment, you are using 5 test tubes, many test tubes together, and all the reactions are different reaction you are carrying out. But mind, all the reactions are carried out only 1 atmospheric pressure, because all are under 1 atmospheric pressure only. They are open, and you also know in the most of the reaction, in the most of the like practical experiment in the laboratory, all the reactions are carried out in open vessel, mostly in open vessel, and those reactions are actually at constant pressure. So those are all isobaric process you can tell. So what simply I want to tell, कि whenever any reaction is carried out in laboratory in an open vessel, that will be an isobaric process. Here also the difference of pressure throughout the process will be zero. So delta P is the mathematical right term. Next is isochoric process. In the isobaric pressure was same, then isochoric volume will remain same. See the definition? Any process during which volume of the system remains constant is called an isochoric process. As I had written here delta P equal to 0. So what has to be written here now? On the statement, a reaction carried out in closed vessel is an isobaric process. Normally in the laboratory, very few reactions are carried out in this way, no doubt. But if the volume remains same throughout the reaction, then it will be called isochoric process. Anyway, as I told you, here delta V will be equal to 0. So these are the mathematical expression you have to remember. Isothermal, that was isothermal in the earlier slide, delta T equal to 0. It is isobaric, delta P equal to 0. It is isochoric, it is delta V equal to 0. Next is adiabatic process. Adiabatic process is like the process in which you will not allow to exchange heat between system and the surroundings. A process in which there is no exchange of heat between the system and the surroundings is called an adiabatic process. Means the boundary wall of the system is not permeable to heat. You are not allowed to get in or come out the heat from the system. This kind of processes where heat is not allowed to get in to the system or come out of the system are called actually adiabatic process. In case of adiabatic process, mathematically what we can write, Q is equal to 0. Q is a symbol of heat, notation of heat, so Q is equal to 0. Here one thing I wanted to tell, in case of isothermal, there was the mathematical relation delta P equal to 0. Here isobaric delta P equal to 0. Here isochoric delta V equal to 0. But here we have not written delta Q. This term you have to remember, dear student. This heat is not a state function. It depends on the intermediate steps. So this is the case, in case of heat, in case of non-state function quantities, delta is not written. So that is why, since heat is not a state function, so difference of heat is not written. It is only Q equal to 0, because delta Q is not applicable in case of non-state function. So that you have to remember. If the process is exothermic, the temperature of the system raises, and if it is endothermic, temperature drops. Because see, you can compare with the isothermal process. In the isothermal process, for exothermic, heat was given out in order to keep the temperature fixed. In isothermal process, endothermic heat has to be come into the system, so the temperature has to remain fixed. But in adiabatic process, since the heat is not allowed to go out or come in, so temperature has to be increase or decrease inside. That is the statement. If the process is exothermic, the temperature of the system rises, increases, and if it is endothermic, temperature drops down. So in adiabatic process, actually, the temperature changes throughout the process, which is not in case of isothermal process. There is a difference between adiabatic and isothermal process. Anyway, the different type of processes have been discussed, may be conducted now reversibly and irreversibly. These are also the process. But whatever process we have discussed, like isothermal, isobaric, isochoric, adiabatic, these processes are there, but those processes can be carried out in another different two ways. Those may be reversible and or irreversible. Means an isothermal process can be carried out either reversibly or irreversibly, right? An isobaric process can be carried out by reversibly or irreversibly. That is the meaning. Those processes can be carried out in another two different ways, reversibly and irreversibly. First, I'm talking about the reversible process. As you have applied, as you have introduced this word many times, many ways, many places, actually, reversible. But your scientific definition of reversibility is completely right. Conceptually, you have to understand it. See the definition and you just think what you understood. Any process in such a manner, any process takes place in such a manner that at every stage the driving force is only infinitesimally greater than the opposing force, and which can be reversed by a slight increase in the opposing force, is called a reversible process. I don't know whether you understood the right word used in this statement, but thing is that here one word is used infinitesimally. Infinitesimally, infinite, decimally is very means small quantity. Infinite, infinitely small. That is together it is written infinitesimally, infinitesimally small, yeah, infinitesimally greater. Means very right small difference. So this is what the case. Now definition I'll go through again. Any process in such a takes place in such a manner that at every stage the driving force is only infinitesimally greater than the opposing force. The next two different words are coming is driving force, or driving force and opposing force. Suppose driving force, just to explain the driving and opposing force, what I can tell. Suppose in our earlier example, the piston was moving down, moving up and down. Suppose the piston is moving up. Just to move up, the internal pressure has to work on it. This internal pressure will be called driving force. And the external pressure, which is opposing it, that is called opposing force. So this is the simple example. The driving is the movement towards which the force is the force and the movement, right? The directions are same. So that force will be called driving force. And if the movement of the piston is opposing that force, that is called opposing force. And in this case, in this definition of these two forces, the difference is very minimum. That is infinitesimally small. That is the definition. In any process, if there is very small difference, very small, infinite decimal difference between that driving and opposing forces, then the obviously process will take place very slowly. It will take infinite time to complete, infinite time for completion. If any process is carried out in such a way that the driving and opposing forces are differ by infinitesimal amount, obviously they will take long time, infinite time for completion. This kind of process will be called always a reversible process. See the concept you had in your mind. What concept you had in your mind was that reversible reactions. You know, any reaction proceeding forward and backward is reversible. But here the concept is right, the bit different, no doubt. So any process, any of a system, any process taking place very slowly, infinitesimally slowly, and the driving force and opposing force differ by infinitesimal amount, this kind of process will be called a reversible process. See few animations and few terms regarding reversible process. Same system I have taken here. Certain amount of gas is enclosed. Piston is fixed here. So it is in equilibrium in this state. So consider the piston moves from A to B. Initial position was A and final position is at B. Piston moves from A to B. So while it was right, it is a movable piston as I told you. So here the pressure will be called external pressure, designated as PEXT, and it is a driving force because I am talking about the compression. Piston will move in this direction A to B. So the movement of the piston and the right force exerted, they're in the same direction. That is, this will be called external pressure, will be called driving force. Now this will be the opposing force then, internal pressure designated by P, and is the opposing force. Internal pressure is opposing force at the time of compression I'm talking about. So when the piston is coming down, then this external pressure will be the driving force and the internal pressure will be the opposing force. Now I'm going to explain what will be the reversible process, how this process from the process means the piston is changing from A to B, moving from A to B. This process, how it can be carried out reversibly. Anyway, see, at point A, while the piston was fixed at A, then P means internal pressure and external pressure was same. And that is why the piston was fixed at A. Let me consider at this state the external pressure and internal pressure both were 1 atmosphere pressure say. And since internal pressure and external pressure are same, that is why piston was fixed here. Now let me do one thing. Let me think in this way, explain in this way. If P is 1 atm, means internal pressure is 1 atm, and I increase the external pressure suddenly at 2 atmosphere, then what will happen? The piston will suddenly move. Piston will move from A to B suddenly. So this is the process. Whenever this external pressure is increased up to 2 atmosphere and internal pressure is still at 1 atm, then piston will suddenly move down, right? And once the piston will come at B, again there has to be this internal and external pressure has to be equal. मीन्स पिस्टन यहाँ पे आने के बाद जब अंदर का प्रेशर भी 2 atm हो जाएगा, बाहर का प्रेशर तो 2 atm है ही, तो पिस्टन विल अगेन भी स्टेबल है, पिस्टन यहाँ पे और एक बार फिक्स्ड हो जाएगा. Got it? So this is what the case कि once the piston is coming suddenly from A to B, that process will be called an irreversible process. Mind, यहाँ पे जो piston A से B suddenly आ गया ना, this kind of process will be called irreversible process. It takes place in very short time. It is a fast process. Now, let me think in other ways. Internal pressure 1 atmosphere है, internal pressure is 1 atm, and P external I increase, no doubt, not directly at 2 atm. I increase P external up to from 1 atmosphere to, initially it was 1 atm, from 1 atmosphere to 1.0001 atm. इसका मतलब जब एक्सटर्नल प्रेशर में 1.0001 atm तक इंक्रीज करूंगा, internal pressure is P only, 1 atm only. तभी what is the difference between internal and external pressure? It will be difference between these two will be 0.0001 atm. Now you tell me, at this difference, how much piston will move down? It will be very negligible. Means the piston will come in such a position that you will not be practically able to distinguish it. But since there is difference between the pressure, the piston will come down. But piston will come down so minimum that you'll be neglecting it. There will be negligible change in the position of the piston. Got it? Next time, whatever changes was there, I could not measure, it's okay. Next time I increase the pressure, external pressure by 1.000, 1.0002. Again, the difference is same only, 0.0001 only, because here in this state, that was that much 1.001 atm. I increase the pressure by another 0.001 atm. So total pressure has become 1.0002 atm. And this way I'm increasing slowly, and you see this data and obviously long time it will be taken. Many number means a large number of steps will be there, and ultimately these way whatever piston changes is there every time, it will be very difficult to decide. So the concept is, so whenever the piston was changing so minimum, it was very difficult to detect how much the position of the piston has been changed, right? But this way I carried out the process, suppose 10,000 times, suppose 100 times, 1,000 times I carried out. So once it is carried out 1,000 times, then you see whatever, no doubt the changes, every time the changes was very small, infinitesimally less. But the same process when carried out 1,000 times, then obviously there will be large difference. And see here the calculation, I'll show you. Ultimately, after doing right so many times, once it will come again to 2 atm pressure. So once the 2 atm pressure will be, obviously a piston will come here itself, as we did earlier in the irreversible process from A to B. It then time it came suddenly because external pressure was suddenly increased by 2 atm. लेकिन यहाँ पे क्या हुआ कि जब मैं इतना कम कम करके इंक्रीज कर रहा था प्रेशर, एक्सटर्नल प्रेशर इतना कम कम करके जब इंक्रीज कर रहा था, तो एवरी टाइम there was no difference because the difference was very negligible. But whenever the same process is carried out so many times and ultimately the external pressure has become 2 atm, then obviously piston will move here itself. Means the movement of the piston is so small that every time it seems to us that there is no difference. In every steps, there is no difference. It means what we can say कि जो हर स्टेप में एक एक करके छोटा छोटा स्टेप हो रहा था infinite number of times. Sorry. So I'll go back. ये जो infinite number of steps involve हो रहा था यहाँ पे, in that infinite number of steps, the difference was negligible. It means the system was in a state of equilibrium every time. And finally, the position of the piston has changed from A to B. Means throughout the change from A to B, the system was in a state of equilibrium. Because हर step इतना कम था, इतना छोटा था कि जो भी step involve हो रहा था उस step में the change was negligible. So no doubt the process, it seems to you maybe impractical, yes, is right, hypothetical, no doubt. It will be very difficult to carry out. But remember, this kind of processes will be called reversible processes. So let me summarize all the characteristics in this way, point wise. The features of reversible process. First of all, as I told you, the driving and opposing forces are infinitesimally less, right? Different from each other. That difference is very minimum, very negligible. Second, the process can be reversed at any point during the process by making the infinitesimal change in conditions. Means every time वो जो हम एक एक step discussion कर रहे थे, right? 1.0001, then 1.0002. So they are actually in equilibrium. So at any moment, initial state can be final, final can be initial, like that. So these are the case. Every moment the process can be reversed also with a very small change. Third point, the process takes place in infinite number of steps. As I told you, it will take long time, infinite time, because infinite number of steps are involved. At the end of every step, the process, the system maintains equilibrium, right? Means every steps, whenever every steps were involved, the system was in a state of equilibrium. Fifth point is the maximum work is obtained during the reversible process. This is very difficult. Now it is bit difficult to understand. What is the maximum work? What is the concept? That is why I just highlighted it. I'll explain in details, right? In our ongoing next discussion. So I'm not explaining this. The maximum work is obtained during the reversible process. I shall make you remember that one point was highlighted in the features of reversible process then time. Okay, you just remember it. In a reversible process, maximum work is obtained. That's all. Sixth one, the process takes place so slowly that the system is always in a temperature pressure equilibrium with the surrounding. Obviously, as I told you, in each and every step the system was in equilibrium. Got it? So these are the different characteristics of reversible process, features of reversible process. In examination also they ask, write the features of reversible process. So these are the points you have to write. Next, as I told you, irreversible process, on the other hand, you know, this is a fast process. It takes place, right, uh, in a single step. That is also, it is also called a single step process. And during the process, there will be no involvement of equilibrium. Just against this, whatever point we have discussed, against all this point, it reversible was a slow process, irreversible is fast. There is equilibrium throughout the process. Here, no equilibrium during the process, right? So there in the reversible process, infinite number of steps are involved. Here only single steps will be involved. Anyway, a process which is not reversible is called an irreversible process. Simple statement. The difference between driving force and opposing forces is very large. In an irreversible process, very important statement, all irreversible processes are spontaneous process, and all natural processes are spontaneous process. Thus, all natural processes are, thus all, sorry, here thing is all, this thing, all reversible process will be, hold on, here the printing mistake, a typing mistake. Just a minute. Going back. Here it is a typing mistake. You have to understand what I wanted to write actually. All irreversible processes are spontaneous, and all natural processes are spontaneous, and thus all irreversible processes are spontaneous. I think you understood. Here it is. This word is irreversible. Irreversible are spontaneous, and all spontaneous processes are natural processes. So all irreversible processes are spontaneous process. Got it? Next is all irreversible process, whether natural or spontaneous, tend to occur in direction that will lead to equilibrium. So this is a very important statement, right? Whenever any irreversible, suppose I am talking about and giving example, suppose water is falling from higher level to lower level. It is a natural process. It will flow without help of any external agency. It will flow constantly, continuously. That is spontaneous. And obviously it is an irreversible process. Got it? So this is the example. Water is falling from higher level to lower level is an example of irreversible process, because it is a natural process and it is a spontaneous process. And once the water is, right, once water is come down, suppose in a whatever that stagnated position is there, stagnated what I'm talking about, it is again in a state of equilibrium. So this is the case. Whenever any spontaneous process we are talking about, that has to be natural process, and that has to be irreversible process. This is a characteristic of irreversible process. Examples, as I told you, water always from of its own, from higher level to lower level spontaneously, is an example of irreversible process. Second example, heat always flow from hotter body to colder body spontaneously, is an example of irreversible process. A cup of hot coffee placed in a room cools down of its own by releasing heat to the surroundings spontaneously. It is an example of a reverse process, right? Simple example, right? Once the hot coffee cup is kept, after some time it will be at room temperature. That is, heat will flow spontaneously. You don't have to work on it. Automatically, heat will dissipate to the surrounding, and ultimately, temperature will drop down to room temperature. So this is what the case with the examples of irreversible process. I think, dear student, you understood. The most important concept was reversible process. Hope you understood. Reversible process are a very slow process. Infinite number of steps are involved, and each and every step there has to be some equilibrium, right? The system should, during the process, the system should not deviate from equilibrium. It is a very prime condition of a reversible process. And on the other hand, irreversible processes without any equilibrium, very fast process, single step. And these are the examples we have seen. So hope everyone understood. Next thing is coming about distinction between isothermal and adiabatic process. Earlier what we told, this isothermal adiabatic. Simple example. Isothermal process and adiabatic process, temperature of the system remains constant. Temperature of the system increases or decreases because heat is not allowed to go in or come out. Second, there is exchange of heat between system and the surroundings. As we told, as we discussed, there is no exchange of heat between system and the surroundings. The internal energy of the system remains constant. The internal energy of the system may increase or decrease. Regarding internal energy, we have topic we have to discuss in details. So I will discuss these right in at length, but not now. We have to remember internal energy, right? We have this is a term I'll discuss in details. Fourth one, the system is not thermally isolated from the surroundings. The system is thermally isolated, right, from its surroundings. Means heat exchange, the system is embedded, surrounded by thermally, right, impermeable boundary. The heat is not allowed to come in. Anyway, these are the difference between isothermal and adiabatic process. And also you can find out difference between reversible and irreversible process. I have not added here. That is that will be your homework. So here the homework set 1. Define the following terms. You have to write all this in your notebook. Explain the term state function. Give 2 examples of state functions. 2 examples of non-state functions. Explain thermodynamic equilibrium. Distinguish between isothermal and adiabatic process. Here another question you can add. Distinction between reversible and also irreversible process. You have to write. So what is a reversible process? What are its features? So these are the different questions you have to write in your notebook. So today, ultimately, in this lecture, I think whatever concept you understood well, we started from equilibrium. It's a very important concept. Then based on equilibrium, we had some processes like if it is in thermal equilibrium with the process, isothermal process. Then pressure equilibrium, isobaric process. Volume in equilibrium means not changing, isochoric process. Heat is not allowed during the process, adiabatic process. Then all these processes can be carried out in another 2 different ways, maybe reversible or irreversible. Then we discussed what about the reversible process, what are the irreversible process, their characteristics, their examples. Here another thing I'll mention, you will not get to see, you will not get any practical example of reversible process because it is a hypothetical idea, right? But only the examples what you will get is of irreversible process. Numerous number of examples you'll get because all natural process are reversible. So examples of reversible process is difficult to practically see because it practically does not take place, practically does not happen. Fine. So even if you ask me why then it is practically does not happen practically, the concept of reversible I'm talking about practically hota bhi nahi hai, फिर भी why we are discussing in our this kind of thermodynamics is experimental science, प्रैक्टिकल साइंस यहाँ पे क्यों डिस्कशन हो रहा है जो प्रैक्टिकली होता नहीं, रिवर्सिबल प्रोसेस. Mind, using this concept, certain things can be solved very easily. रिवर्सिबल वाला जो कंसेप्ट है, ये कंसेप्ट यूज करके कुछ प्रॉब्लम, कुछ थिंग्स can be very easily solved using this idea, and that is why it is important for our thermodynamics. So dear student, You just write down all the answer of all the questions very neatly in your notebook, and you maintain one notebook separately, so that all the questions will be there. You have to write the answers accordingly. In the next ongoing lectures, even I'll write foregoing lectures, I'll ask you some questions also, so better you should understand clearly. uh, for today I want to stop here.